Hi, everybody. Welcome to part 3, the third video answering part of exercise 14 from section 2.1. Namely, if V and W are vector spaces and T is a linear transformation, then part C says suppose that beta is a basis for V. We'll call beta the vectors V1 through Vn. And we're also going to suppose that T is 1-to-1 and on 2. Then we're going to prove that T of beta is a basis for W, namely that the set consisting of T of V1, T of V2, T of Vn, T of each of these vectors from beta, that set is a basis for W. So let's get started. We start off with beta, a basis. Beta is a basis for V. So we know two things about a basis. We know that beta is linearly independent, and we know that the span of beta is equal to all of V. We'd like to show the same kind of thing for T of beta, namely that T of beta is linearly independent and that the span of T of beta is equal to W. So we want to show that T of beta is linearly independent and that the span of T of beta is equal to all of W. Well, one of these looks like it's pretty well what we just showed. We start off with a linearly independent subset of V, namely beta, and we conclude that T of beta is also linearly independent. Well, in part A, we could do that if we had that T was 1-to-1. So by part A, since T is 1-to-1, in part C, we're assuming that T is both 1-to-1 and onto. And since beta is a linearly independent subset of V, we know that T of beta is a linearly independent subset of W. Great. That is half of what we wanted to show. So all that remains now is to show that the span of the span of T of beta is equal to W. So what do we know? Well, we know something about the span of T of a basis by theorem 2.2. Look it up in the book, check that this is the right number. By theorem 2.2, since beta is a basis, the span of T of beta is equal to the range of T. All right, so this is true for any linear transformation. Theorem 2.2 says that if you have a linear transformation and beta is a basis for the domain, then the span of T of beta is equal to the entire range. Now that doesn't tell us automatically that T of beta forms a basis for the range, although in this case, we know that T of beta is linearly independent, so actually it does. In this case, we know now that T of beta forms a basis for the range of T. But we want to show that T of beta forms a basis for W. So we need to somehow relate the range of T to W. Right. In part C, we're supposing that T is both 1-to-1 and onto. Since T is onto, what this means is that the range of T is equal to the entire codomain W. So with these two lines together, the span of T of beta is equal to all of W, since the range of T is W. And that was the last thing we wanted to show. We showed that T of beta is linearly independent, and we showed that T of beta generates all of W. we have thus shown that T of beta is a basis for W. Hopefully that was helpful. I will see you guys on Tuesday.